So this is question number 41 of GATE 2021 Metallurgical Engineering. The question is, liquid iron is cast into a spherical sand mold 6 centimeter radius and a cubical sand mold 12 centimeter edge length. If solidification time is 60 minutes in the spherical casting, then the time required to solidify in the cubical casting is. So in order to understand the detailed concept behind this problem, you can refer NPTEL Lecture 4 on Principles of Casting Technology course by Professor Pradeep K. Jha from Department of Mechanical and Industrial Engineering, IIT Roorkee. So let us first understand the solidification time in the casting. So the solidification time is mainly dependent on two main factors. The first one is the volume, volume of casting, and the second one is the surface area of the casting. So in order to calculate the time required in solidification, we have a rule called Korinov's rule. So the rule says the solidification time, which can be denoted by Ts, is proportional to the ratio V by A to the power n, and V by A is nothing but volume to area ratio to the power n. So if you simplify this, then we will get Ts is equal to Cm into V upon A to the power n, and Cm here is the proportionality constant, which is also known as mold constant, and it is basically dependent on the mold material, what type of material you are choosing for your mold, what is its thermal property, as well as like what type of material it is made up of. So this the value of Cm will be dependent on that factor, and n here is an exponent, and which will be equal to 2 for metals. So in our case, since it is iron, we can use n is equal to 2 for our solution. Now we will consider first spherical shape mold to calculate the solidification time, or like to establish the relation with the help of this Korinov's rules. So for a spherical mold, Ts is equal to Cm in V upon A to the power 2. Now in case of a spherical, the volume can be written as 4 by 3 pi r cube, and r we have been given that it is 6 centimeter, and similarly area value can be written as 4 pi r square, and the value of r we can put it as a 6. So if you simplify this, we will get the relation Ts is equal to 4 times Cm, and Cm is nothing but the mold constant. Now in this case, we have been given the value of solidification time, that is 60 minutes. If you see, the solidification time is given as 60 minutes in the case of spherical casting. So by putting the value of Ts as a 60, you will get the value of Cm is equal to 60 upon 4, which will be equal to 15. So from this calculation, we got the value of Cm as a 15. Now we will consider the case for cubical mold. So let's say for a cubical mold, the solidification time is denoted by Ts bar. So similarly, we'll write the relation Ts bar is equal to Cm times V upon A to the power 2. Now you simply put the value of V and A. V, that is volume of a cube, which will be equal to A cube, and A, the value of A is given as 12 centimeter here. So 12 cube upon area. Area of cube will be equal to 6 times square of side length, which will be equal to 6 into 12 square. So if you simplify this, you will get Ts is equal to 4 times Cm. Now As we know, all the conditions are same in both except the geometry. Here it is spherical mold and here it is cubical mold. So the value of Cm which we have calculated earlier will be remain same here as well. So here we know the value of Cm, but we have to calculate the value of Ts bar. So simply putting the value of Cm is equal to 15, we will get the Ts value 4 times 15 equals to 60 minutes. So from this we easily get the value of solidification time in case of cubical mold, which will be equal to 60 minutes. So that will be the correct answer for this question. Thank you.